Yeah, peeps, Tersse back in old squat walks talking about physics again, right? We all know that people say, the vacuum isn't empty. Whenever you measure the vacuum, we see these particles popping into existence and then annihilating themselves and disappearing out of existence. It happens all the time. Every time we've tried to do this test, we've seen it happens. But the thing is, we've only ever done that here, on Earth. You know what I mean? What if that only happens when you're close to an actual mass body? A body that has mass, a body that's producing energy, like a body like the Earth, or maybe you need to be close to something like a sun. I mean, we, as I said before, we have got no idea what happens, not even outside of our solar system. We don't even know if space acts the same way beyond our solar system. We know that a lot of stuff, a lot of physics in space acts the same. We know that light travels through space. We know that we get we've supposed tachyons. I'm not sure if we've detected them yet, but perhaps we have tachyons. We know that these elemental particles that we've already detected, we know that they probably travel through space. But do we know that, what we see in a vacuum, what we call a vacuum here on Earth, do we know that that happens beyond the edge of our solar system, beyond the edge of our galaxy? Do we know that there's no difference in the frequency as we get outside of our solar system? Maybe by the time we get outside our solar system and get, halfway between our star and the next star, maybe we might see a slow, or a small reduction in the amount of atoms that appear in a vacuum and disappear. Maybe if we could get outside our galaxy, between our galaxy and the next closest galaxy, we might see that it almost disappears completely. This, spontaneous production of atoms in a vacuum. We don't know. These are questions that I would be asking as well. Is this a standard throughout the universe? Or is this only something you would see close to a body which is giving off lots of energy which we might not be able to detect at the present day? The sun could be giving off lots of energy that you wouldn't be able to detect, halfway between our solar system and the next sun. The suns within our galaxy could be giving off energy that we can't detect between our galaxy and the next galaxy at all, and that might have an effect upon whether or not atoms appear and disappear in a vacuum. We don't know everything. We really have to start asking ourselves these difficult questions. Is this a standard, or is this just something that we see here because of our position in the universe? And until we actually get to the point where we can send spaceships between solar systems, and then possibly between galaxies, we're not going to know the answer to the question I've asked. But I would posit it as a question that we should be asking ourselves. I'm not saying that atoms don't spontaneously appear within the vacuum on the surface of the Earth, but you've got to remember we are very close to huge, gigantic gravity machines, planets, the sun, and they could be producing energies which are causing that effect within what we call vacuum, but might not have such a great effect within the vacuum at a farther distance. So I'm just saying, we understand that can happen. I mean, electricity, the electromagnetic field that we all know exists and is a huge part of physics, it normally has a greater effect on things depending on the experiment you do, and the closer you are to whatever's producing the electromagnetic field. We understand that as you get away from the electromagnetic field, you get a weaker response and weaker detection of the things that the electromagnetic field does. Could that possibly be the same for large gravitational fields? For instance, if you get outside the the gravitational well of the sun. I mean completely outside the gravitational well of the sun by leaving the solar system and getting somewhere equidistant between one gravitational well, that is one sun, and another. Would you not see a difference in what would happen to certain experiments that might be affected by that gravitational field or the electromagnetic field produced by a spinning sun or a spinning planet? I'm just saying, I'm just positing questions for physicists, and I don't believe they have any answers, but it might buck them up to actually start to think of these questions that they're answering with these cute and relatively, I would say, relatively sort of like, well, everybody else believes it, so it's right just to go along with it. I've never been a joiner. I'd like to question the idea that gravitational fields and electromagnetic fields don't have any effect upon a vacuum. I think they probably do. We might not know what that effect is yet, because we've always done our experiments within the location of an electromagnetic field and a gravitational field. What would happen if we could get further and further away from these things and then do the same tests? That's what I'm asking. What do you think? Is there any way to physically test that? Mathematically test it? Is there any way we could check these things out? Probably not on the surface of the Earth, but probably we could do it if we could get some explorer leaving the solar system to do a test once it's left the solar system, and then radio us the message back, which we'd get in about 80 years or 100 years. I wonder if they put any tests like that on the voyger that we sent spinning out the universe, spinning out the solar system. I wonder if any tests like that were set up to be turned on at a specific point of the voyager recognising its distance from the sun or whatever. I would be really interested to know if anything like that was actually put on that probe. You would think that brighter minds than me, when they built it, might have thought of something like that to put on that spaceship. The billions of pounds it cost to develop and send off into space, rocketing through space, playing the dark side of the moon or whatever it is they put on it. Handel's Messiah, I don't know. You'd think they'd put some real science sort of stuff on there as well, you know what I mean? 25 motherfuckers.